Hello, you're welcome to the Math Classroom. Thank you to my subscribers. If you are new to my channel, kindly don't forget to subscribe, like, and share among your networks. In our previous lesson, we looked at eigenvalues and eigenvectors, and we established that if I have a matrix A times our vector x is equal to what? Lambda x, where lambda is our eigenvalues. And we established this homogeneous equation. We said x here is what? A non-zero vector. And to find your lambda, using the characteristic equation, we said the determinant of this equal to 0. Arriving at your characteristic equation and finding the roots will give us what? Our eigenvalues. In our lesson today, we still want to take some examples and find what? The eigenvalues and eigenvectors. So let's take an example again today. So if I have a matrix A, so example, we want to find the eigenvector vectors of the matrix. So let's say our matrix A is equal to A is equal to 4, 1, 3, 2. This is the matrix A. So let's find what our eigenvalue. What did we say? We said the determinant of what? A minus I lambda is what? Equal to what? 0. Because it's what? A 2 by 2 matrix. What is our identity matrix? Is what? 1, 0, 0, 1. Good. This implies that my lambda I is going to give me what? Lambda 0, 0, lambda. So if I have A minus I lambda, what is A? My A is 4, 1, 3, 2 minus lambda 0, 0. This is going to be equal to what? 4 minus lambda 1, 3, 2 minus lambda. If I take the determinant of this, so the determinant of A minus I lambda is going to be equal to 4 minus lambda 1, 3, 2 minus what? Lambda. So let's find the determinant. This will multiply that. So I have 4 minus lambda times 2 minus lambda minus 1 times what? 3. If you simplify, what do you have? You have what? Lambda squared minus 6 lambda plus 5 to be equal to what? 0. And this is going to give us lambda minus 1 lambda minus 5 to be equal to 0. So from here, what will be lambda? Realize lambda 1 is going to be equal to 1, and lambda 2 is going to be equal to 5. So we know the eigenvalues for the matrix 4, 1, 3, 2. So with the eigenvalues, why don't we find our words eigenvectors for each corresponding eigenword value? So we find eigenvectors. What did we say? We said, so let's pick for each one. So for lambda 1, so let's say for lambda 1 to be equal to 1, we established that AX, we know our AX to be equal to what? Lambda what? X. So what are we looking for? We want to find the value of what? X, which is what? Our eigenword vector. So I have A. A is what? 4, 1, 3, 2 times my eigenvectors, which is what? X1, X2 to be equal to my lambda. My lambda is 1 times what? My X1, X2. If you multiply this, you realize that I have what? 4 times X1. So I have 4X1 plus X2 to be equal to what? X1. And 3X1 plus 2X2 to be equal to what? X2. So I have these two simultaneous equations. I could solve to get what? X1 and X2. I could solve to get what? X1 and what? X2. So let's solve for X1 and X2 here. So if I take this, let's say this is 1, this is 2. So for 1, you realize that I can express X2 to be what? X1 minus 4X2. And this is going to be what? X2 to be equal to minus 3X1. 3X1. If you do same for here, you realize that, so from here, if you do the same thing, you get the same result. So we can say that, so let me write this. You realize that this is going to give us 3X1 to be equal to X2 minus what? 2X what? 2. So that I have 3X1 equal to what? Minus X2. Multiply through by negative, and this could equally be expressed as what? X2 so this could equally be expressed. Let's look at it. So you realize that this, I have this here. This also implies that my X2 is equal to minus what? 3X1. What does it mean? This means that whatever value of X1 I have, whatever value of X1 we have, the value of X2 is minus 3 times what? X1. So that's my eigenvector. So whatever value of X1 I have, so whatever value of X1 I have, 1, is what? 3 times X2 is going to be minus what? 3 times that. So that for lambda 1 to be equal to 1, we have the eigenvector to be what? Minus 1 and what? 3. Minus 1 and 3. So I can conclude and say that the eigenvector for lambda 1 to be equal to 1 is 1 minus what? 3. Now let's find the corresponding eigenvector for lambda equal to 5. So for lambda equal to 5, so for lambda 2 to be equal to 5, what do we have? We have ax to be equal to what? Lambda x. This implies that I have a. What is my a? A is 4, 1, 3, 2 times what? 1 x2 to be equal to 5 x1 x2. This implies that I have what? 4x1 plus x2 to be equal to 5x1. Then I have 3x1 plus 2x2 to be equal to 5x. So this implies that what? I have x1 to be equal to what? X2. If you simplify this is what you have. So this implies that 1 for x1 x2 is a solution. It's a solution. I say it's a solution corresponding eigenvalue 5. So you realize that for eigenvalues for lambda 1 to be equal to 1, we have a corresponding eigenvector 1 minus 3. And for lambda 2 to be equal to 5, we have its corresponding eigenvector to be 1, 1. I might say that there are ways you find your eigenvector aside using the formula ax minus lambda x to be equal to lambda x. So you could as well use your determinant equation to find what you could use this to find what your eigenvectors, because you know the value for eigenvalues lambda, you could write this and equate towards 0. You could write this and equate to 0. Then you can find your values of words, your eigenvectors x here that we initially had. Let's take another example. If I take another example, we want to look at a 3 by 3 matrix. So example 2, let's say I have the matrix A to be equal to 2, 0, 1 minus 4. So 2, 0, 1 minus 1 minus 1, 4 minus 1, then minus 1, 2 and 0. This is the matrix I have. We want to I find what the eigenvalues, then 2 find each corresponding eigenvector for the eigenvalues we have. So let's find our eigenvalues for I. what do we have? We have the determinant a minus I lambda to be equal to 0. So for a 3 by 3 matrix, what do we have? We have I to be equal to what? 1 0 0 0 1 0 0 0 1. That is the identity matrix. So for lambda I, what do we have? Lambda 0 0 0 lambda 0 0 0 lambda. So that if I have a minus I lambda, what do I have? I have 2 0 1 minus 1 4 minus 1 minus 1 2 0 minus I lambda, which is lambda 0 0 0 lambda 0, then 0 0 lambda. This will give us 2 minus lambda. You have 0, you have your 1, then I have minus 1 here. I have what? 4 minus my lambda minus 1, then minus 1 2 minus what? Lambda. So this is what I have. Now let's take the determinants of that. So if I find my determinants, so I have determinants of a minus I lambda to be equal to what? 0. This implies that I have what? Finding the determinant 2 minus lambda 0 1 minus 1 4 minus your lambda. You have minus 1 here. Then we have minus 1 2 minus lambda. This is equal to what? 0. So let's find our determinants. So we've already learned determinants in our previous lesson for a 3 by 3 matrix. If you've not watched the video, I urge you to kindly watch the video on finding the determinants of a 3 by 3 matrix. This implies that we have 2 minus lambda. You find the, then I have what? Minus lambda 4 minus lambda plus 2. Then I have what? Plus 1. Don't forget this part, because it's 0, everything multiplied will go to 0. So I have that. So I have plus, you have your minus, and you have your plus. So I have 1 minus 2 plus 4 minus lambda to be equal to 0. If you simplify, you realize that we have what? 2 minus lambda. This is going to give us lambda squared minus 4 lambda plus 2 plus, this is also going to give us 2 minus lambda, which is equal to what? 0. So this implies I have what? 2 minus lambda. I have what? Lambda squared minus 4 lambda plus what? 3 here, which is going to be equal to what? 0. Okay. So let's find the roots. So we have 2 minus lambda to be equal to 0. So we have lambda to be equal to what? 2. Then if I take lambda squared minus 4 lambda plus 3 to be equal to 0, this is going to give us what? Lambda plus, is going to give us lambda. So I have lambda minus 1 lambda minus what 3 to be equal to what 0. This implies that I have lambda to be equal to 1 and lambda to be equal to 3. So I have 3 roots for lambda. So we have what? So what do I have? You realize that I have, let's say, lambda 1 to be equal to 1, lambda 2 to be equal to 2, and lambda 3 to be equal to what? 3. Okay, so now let's find the eigenvectors for each corresponding eigenword. Values. So we'll first do that for lambda 1. So let's do for lambda 1 to be equal to 1. What do we have? We have ax. So I have minus 1, 0 and 1. Then I have minus 1, 3, minus 1. Then I have, okay, so I have, once again, 1, 2, minus 1. I have x1, x2, x3 to be equal to 0, 0, 0. So you may be wondering, how did I arrive at this? So we initially said we have what? A minus I lambda to be equal to x, it's equal to what? 0. What is A? We know the values for what? Lambda. So for lambda 1, you realize what was my initial A? The initial A was, I had was, this was what? 2. This was 2 minus lambda 0, 1. We had minus 1. 4 minus lambda, then minus 1 here. Then I had minus 1, 2 minus what? Lambda. Then I have what? x1, x2, x3 to be equal to what? Your 0, 0. Okay, so for lambda equal to 1, if you subtract 2 minus 1, you realize that you have what? 1. So I have 1 here. I have 1. I have 1. Then 4 minus 1, you have 3. Then minus lambda, it's your minus 1 here. So then let's solve for, now let's solve for our x1, x2, and x3. So this implies that you realize that you have what? I have x1 plus x3 to be equal to 0. Then for the first part, then I have what? x minus x1 minus x1 plus 2x2 minus x3 to be equal to 0. So this, if you check this is going to be what? X3 to be equal to what? X1. Then this implies that minus x1 is going to be plus x2 plus x1, because we are saying that x3 is equal to what? X1, so it's going to be plus minus x1, so it's going to be positive plus what? X1 to be equal to what? 0. So you realize that this cancels that, so I have 2x2 to be equal to what? 0, and this implies that my x2 is equal to what? 0. So that if I want to write the eigenvector, let's say x1, x2, and x3, what do we have? What is x1? We know x1 is what? 1. If x1 is 1, x3 is negative of what? X1, and x2 is what? 0. That is for lambda 1. And if I take for lambda 2, so for lambda 2 to be equal to 2, what do we have? We have 0, 0, 1, minus 1, 2, minus 1, and I have minus 1, 2, and minus what? 2 times what? Our x1, x2, x3 to be equal to 0, 0, 0. We're still using this formula. So this is the formula we are still using. So we are still using this formula to do this. So let's look at it. So from here, you realize we have what? X3. So for the first part, this side, we have what? X3. If you multiply x3 to be equal to what? 0. Then for the next part, this part, we have what? Minus x1 plus 2x2 minus x3 to be equal to what? 0. So we know x3 is 0, so this goes away. So this implies that x1 is equal to 2x was 2. Why? If this goes over, you have negative 2x2, negative cancels, as I have this and that. So simply you realize that for an eigenvector corresponding to lambda equal to 2 is, so we have what is x1? If x1 is 1, x2 is 2 of that, so I have 2 2, x1 is 2 of x2, which is 1, then x3 is what? 0. So this is what I have. Then for the third part, lambda equal to 3. For lambda 3 to be equal to 3, what do we have? We have minus 1, 0, 1, minus 1, 1, minus 1. We have minus 1, 2, and minus was 3 times x1, x2, and x3 to be equal to 0, 0, 0. Don't forget we are still using a minus I lambda x to be equal to 0. Okay, so let's multiply. If you multiply, what do I have? You realize that if I multiply my first row with the column vector, I have what? Minus x1. This times that is 0 plus x3 to be equal to what? 0. This implies that my x1, this implies x3 is equal to what? X1. Then if I pick the second one, I have what? Minus x1 plus x2 minus x3 to be equal to what? 0. We know what x3 is. x3 is minus 1. So this implies I have what? Minus 1 x minus x1 plus x2 minus what? X1. And this is going to give us what? Minus 2x1 minus x2, which is what? 2x1. 2x1 is equal to what? X what? 2. Very good. So from here, you realize that your eigenvector is going to be what? X1. X1 is what? 1. And x2, if x1 is 1, x2 is 2 of x1, so which is 2, and x3 is equal to x1, so which is what? 1. So this is the eigenvector for lambda 3 to be equal to 3. So let's put it together nicely. So in putting it together nicely, I want to say that if I say for x1, that is, let's say for the first eigenvector, I have what? 1, 0, minus 1. It's an eigenvector. It's an eigenvector corresponding to lambda 1 equal to 1, or lambda equal to 1. Then for my second eigenvector x2, I have what? 2, 1, 0, which is also corresponding to lambda 2 equal to 2. And for x3, my third eigenvector, I have 1, 2, 1, which also corresponds to lambda 3 to be equal to 3. Very good. So this brings us to the end of our matrix, finding the eigenvalues and eigenvectors. Practice makes Perfect.